Everyone is building basic chatbots. Everyone. And I promise you, the recruiter reviewing your resume has seen 40 of them today before lunch. So here's the uncomfortable truth. If your AI project is just an open AI API call inside a React frontend, you are not standing out, you are blending in. I'm going to show you 5 AI projects that you should be building in 2026 that will make a senior engineer stop scrolling and actually read your resume. What's up? I'm Aditya. I'm a software engineer, and as a side hustle, I build and sell my own SaaS products. This video is not a listicle I googled. These are the projects I would build or have built if I was trying to break into the top tier engineering role right now. And I'm going to tell you exactly why each one works technically and strategically. So let's get into it. Before I give you the projects, I need you to understand why this matters so much right now. In 2024 and 2025, the bar got absolutely crushed. Every bootcamp, every YouTube tutorial, every intro AI course told people the same thing. Build a chatbot, wrap an API, add a vector database. And people did. Millions of them. So every resume has an AI project. And that means having an AI project is no longer a differentiator. What hiring managers, especially at companies that are serious about AI, are actually looking for now is technical depth. They want to see that you understand the systems underneath, that you have dealt with real engineering problems, evolution, latency, orchestration, data pipelines, things that break in production. The projects I'm about to show you signal all of them. They are harder to build, and that's exactly the point. And quick thing on the recruiter side before we get into the projects, because this changes how you present everything. I have talked to a lot of people on the hiring side, and here's what they told me. When they look at a GitHub project, they are asking 3 questions. First, did this person build something real, or did they just follow a tutorial? You can tell. The commit history is too clean, the README is a copy paste, there is no issues, no branches, no evidence of iteration. Second, do they understand the architecture? Not just it uses GPT-4, but why did they use this chunking strategy? Why this vector store? What are the trade-offs? And the third question they ask is, did they care enough to document it properly? A great README is the way to communicate to the team. So when you build these projects, which I'm about to show you, build them like you are shipping them to real users because the best ones you actually can. So project 1 is a multi-agent orchestration system. The word agentic AI has been everywhere for the past 2 years, but most people still don't actually understand what it means to build one properly. And that's your opportunity. Here's the concept. Instead of a single LLM that does everything, you design a system of specialized agents that each own a specific task, and an orchestrator that routes work between them based on the state and logic. A really concrete example that would read incredibly well on a resume is build a software engineering agent system that can take a GitHub issue as input and autonomously research the code base, draft a fix, write tests, and open a pull request. You'd use LangGraph for the orchestration. It gives you the actual state management between the agent steps, which is critical because the real agentic systems are stateful. They make decisions based on what happened in the previous steps. This is completely different from just chaining prompts together. Each agent is the node in the graph. The edges are conditional, meaning the orchestrator looks at the output of one agent and decide which agent runs next. That's the real control flow. Now coming to tools the agent will use. You'd hook them up to the GitHub API, give them the code search tools, maybe a local code execution sandbox using Docker. And coming on to why this hits. When you can explain in an interview that you understand the difference between a simple chain and a stateful graph-based agent system, and you actually built one, you are showing senior level thinking. And this is what companies like Cognition, Cursor, and every serious AI labs are building right now. Project number 2, a production grade RAG pipeline with an evaluation layer. Now everyone has built a basic RAG app. Dogs go in, you ask questions, it retrieves the stuff, the LLM answers. Fine, but it is boring. The thing that makes a RAG project actually impressive is building the evaluation layer on top of it. Here's the problem that every real company faces. How do you know your RAG system is actually working? How do you know it is actually retrieving the right chunks? How do you know the answers aren't hallucinated? And how do you measure the improvements when you change your chunking strategy? Most tutorial projects never ask these questions. You are going to answer them. Now, RAGAS is a framework specifically for evaluating RAG systems. It gives you quantitative metrics, faithfulness, which is the answer supported by the retrieved context. Then it also gives answer relevancy. Does the answer actually addresses the question? Context, precision, and recall. Is your retriever pulling the right chunks? Build a RAG pipeline over a real domain like legal documents, technical documentations, financial reports, medical literature, something with real complexity. Then build an evaluation harness using RAGAS that you run after every change in the pipeline. Now you want to be able to show a plot. When I switched from native chunking to semantic chunking, my context precision went from this number to this number. Alright? Now this is an engineering result. That's what you put in your resume, and that's what you put in your README. Now why this project hits? Now you have moved from I built a chatbot over a document to I built a retrieval system with measured accuracy and I can prove it improved. That's an engineering project and that's what gets you in the door. Now moving on to the project 3. This project is going to be a local LLM deployment on edge hardware. Now this one is strategically underbuilt. Most people don't do it because it feels harder than calling an API. And that means it's a real differentiator. So what we are going to build is we are going to deploy a quantized large language model to run inference locally on a laptop, a Raspberry Pi, or an NVIDIA Jetson without any cloud API dependency. Now you'd ask me why this matters. So to answer this, a huge category of real enterprise use cases require on-premise AI. Healthcare, defense, finance, legal. These industries are restricted with their data privacy requirements and cannot send sensitive data to OpenAI's server, right? The ability to deploy capable models locally is genuinely valuable, and very few junior engineers know how to do it. Now, you may ask me why this hits. Because you are showing you can work at the model level and not just the API level, and you're solving a real commercially important problem. Now, moving on to the project number 4, and this is an AI powered developer tooling. Build system that other developers would actually use. Now, this is the category that has produced some of the most successful startups of the last 2 years, like Cursor, Codium, GitHub Copilot, because the user is a developer and developers are the most discerning early adapters on the planet. Now here's a concrete project idea. Build a context-aware code review CLI tool. And yes, I'm talking about code review, and that's very important these days. So the tool takes the git diff, the changed code in the pull request, and sends it through an AI pipeline that gives structured, actionable code review feedback. It's not just like this code is bad, it's specific feedback like security vulnerabilities, performance issues, missing error handling, test coverage gaps, categorized by severity, and with line numbers. Now, when you will work on this project, you might get some of the challenges. It's like how do you handle the large diffs that exceed the context window? In this, you'll need smart syncing strategies that preserve the function boundaries. How do you make the output reliably structured? You can use structured output mode with a schema the LLM must conform to, not just free text passing. How do you evaluate the quality? You build a test set of known bad code samples and expected feedback categories. Now, why this hits on a resume? You built a tool for the exact audience that will be interviewing you. It shows taste. It shows you understand developer experience. It shows you can ship something with real utility. And if you open source it and it gets even 200 GitHub stars, and that's a social proof that money cannot buy. Right? Now moving on to the project number 5, and this is going to be a multimodal AI application serving real users. Now this one has a deliberate extra requirement, and that is real users. Not I showed it to my friends, actual strangers using it. And multimodal means the model can understand more than just text. Images, audio, video, GPT-4o, Claude 3.5, Gemini 1.5, these models can all take images as input natively. Most people still don't use this capability. Here's an idea that's genuinely useful. Build a debugging assistant. A user pastes or uploads a screenshot of an error, a terminal output, a UI bug, a graph that looks wrong, and the system gives them the structured diagnosis and a fix. Now this project sounds obsolete, but it has an interesting technical layer. Don't just pass a raw image to the LLM. Build a pre-processing pipeline. Use a vision model to first classify what kind of artifact it is. Is this a terminal error, a UI screenshot, a diagram, a chart? Then route to a specified prompt pipeline for that artifact type. Now this shows your technical depth in this project. Now the real users part. Deploy it. Put it on Reddit, in a Discord server, on Product Hunt. Get people to use it. Screenshot the usage numbers and put that number in your resume. This is what separates the project from products. When you can say in the interview that I shipped it, real people used it, and that's the particular review they have given me. Now these were the 5 projects, and my personal favorite is the project number 4. Okay, last 2 things and I'll let you go. How you present these projects matters almost as much as building them. Here's the exact framework. For the GitHub README, every project needs 4 things. 1. A clear 1-sentence description of what it does and why it matters. 2. An architecture diagram, even a rough one made in XKellyDraw. 3. A results or benchmark section with actual numbers. 4th, technical decision section where you explain 2 or 3 choices you made and why. And this last one is very important. It shows you can reason about trade-offs. For your resume bullet points, don't just write I built an AI chatbot using Python and OpenAI. Write something which shows some particular data. And for interviews, every one of these projects will give you 15 minutes of talking material in a technical interview. They will ask, walk me through a project you are proud of, and you should be able to go deep on the architecture, the problems you hit, and the decisions you made. Practice that story. And here's the thing I want you to leave with. The engineers who are getting the best jobs right now are not necessarily the smartest people in the room. They're the people who can look at a real problem, build something that addresses it, and explain what they built clearly. That's it. These 5 projects give you the opportunity to do exactly that. They are hard enough to be genuinely impressive. They are real enough that you might actually ship something that people use, and they are technical enough that you'll have something substantive to say. So pick one, just one, and build the actual thing. Don't plan it for 3 weeks. Don't watch 5 more videos on this topic. Open your editor, start a new repo, and write the first file. If this was useful, you can subscribe. I make videos about shipping real code and building an engineering career that actually pays. And now go build it. I'm watching you.